Have you ever wondered why a bicycle seems to have a mind of its own? When it's moving, it glides along, staying perfectly upright with very little effort. But the moment you stop pedaling and come to a halt, it wants to fall over. What is the secret science that makes balancing on two thin wheels possible? Think back to when you first learned how to ride. You probably wobbled a lot, feeling like you were about to tip over at any second. It felt almost impossible. Someone helping you might have said, "Just keep pedaling. Go a little faster." It sounds strange, but they were giving you a clue to the physics involved. And then, suddenly, something clicked. You picked up enough speed, and the bike felt stable, almost like it was balancing itself underneath you. This amazing feeling isn't magic. It's a beautiful and clever combination of physics and engineering working together perfectly. Let's look at the hidden problem. A bicycle has a very small base of support. Just two thin patches of rubber where the tires touch the ground. When you sit on a stationary bike, your center of gravity, which is the point where all your weight seems to be concentrated, is high above the ground. Trying to keep that high center of gravity perfectly balanced over that tiny line is incredibly difficult. Any small lean to the side, and gravity immediately starts to pull you down. So why does adding speed solve this balancing act? The first major clue is hidden inside the spinning wheels. Each spinning wheel on your bicycle acts like a gyroscope. This is an object that, when spinning, wants to stay stable. Imagine playing with a spinning top. When you give it a fast spin, it stands perfectly upright, seeming to defy gravity. But as it slows down, it starts to wobble, and eventually, it falls over. That initial stability comes from a principle called the gyroscopic effect. Any object that spins has a property called angular momentum. This is a force that tries to keep the object spinning along the same axis without tilting. Your bicycle wheels are no different. As you pedal forward, the wheels spin rapidly, creating a powerful stabilizing force. This force resists being tilted sideways. It's almost like the wheels are actively pushing back against the force of gravity that's trying to make you fall. The faster you go, the faster your wheels spin, and the stronger this stabilizing gyroscopic effect becomes. This is the scientific reason why going a little faster on a bike actually makes balancing easier, not harder. But that's not the whole story. There's another, even more important secret to a bicycle's incredible balance: the act of steering. When you feel yourself starting to lean to the left, what do you do without even thinking about it? You instinctively steer the handlebar slightly to the left. This small adjustment moves the front wheel back underneath your shifting center of gravity, effectively catching your fall before it even happens. We are constantly making these tiny, almost unconscious steering corrections while we ride. It is a continuous feedback loop between our body's sense of balance and the bike. This explains why it's nearly impossible to ride a bike if the handlebars are locked straight. You lose the ability to make those crucial micro-adjustments for balance. This idea even explains how we turn. To make a right turn, you actually start by making a very quick, slight turn of the handlebars to the left. This is known as counter-steering. This tiny initial movement causes the bike to start leaning to the right, which is the direction you want to go. Then, you naturally steer into that lean to complete the smooth arc of the turn. Your brain learns to do all of this automatically. So the stability of a bicycle isn't from just one thing. It's a team effort between two key scientific principles. The first is the gyroscopic effect from the spinning wheels, which provides a stable platform and resists falling over. The second is the brilliant design of the bike's frame and steering, which allows your brain to make constant, tiny corrections to keep you balanced. A bicycle isn't just a machine you sit on. It's a dynamic system that you, the rider, become a part of. Your body's intuitive sense of balance and the bicycle's clever physics work together in perfect harmony. When you learn to ride a bike, what you're really doing is training your brain to understand and use these forces without needing a single equation. It's a powerful reminder that physics isn't just a subject in a classroom. It's a fundamental part of our world that we can feel and interact with every day. The simple joy of riding a bike is powered by the elegant, invisible laws of science that make our world work.